Okay, so the last thing we need to talk about today is that bit of business on transformation notation. So why do we use transformation notation again? Why on earth would you want to bring out this technique? What's it for? Something to do with transformations, I'll give you that hint.
Stretching and shrinking.
Stretching and shrinking, but there's a very specific thing that we use it for. Like when we work on graphs, well, we don't use this, right? We've been using a different notation and we've been just fine with it. So where would we use transformation notation?
Algebra.
Algebra, it starts with an E, then a Q. Equations, yeah. So this is, again, what we want to think of if we're transforming an equation. Okay? So if there's no graph and you're handed an equation, that's what we're going to use transformation notation for. What's the punchline for transformation notation? What's the one thing you have to remember about it? Yeah, vertical on one side, horizontal on the other. Okay, so in this example, I'm showing you what a vertical and horizontal compression could be because the vertical is on one side attached to y, and the horizontal is attached to x on the other side, so they stay separate. Okay. So just to recap how it works, this would be one way we've done things, and we'd say that the vertical stretch is 1 over a, and then the horizontal stretch here is the reciprocal. Okay. If we've moved it into transformation, that means we'd say vertical go to one side, horizontal to the other. So it would be AY is f of bx. And it's the same equation as the other one, it's just been moved around, so it must have the same horizontal and vertical. But the nice thing again is that the rule is the same for vertical and horizontal. There's not two separate rules, it's the reciprocal for both of them. Okay, but you don't need to remember that part of it. All you need to use this technique for is being able to transform an equation. So let's try it. And we're going to do it on this 3x cubed plus 2x squared minus 6x plus 4. Okay, so here's what we have to do to get started. We have to take this English and translate it into some math. Okay, so step number 1 is to say y equals, and I'll leave some space here. Okay, so these blanks, can anybody fill in one of those blanks after they read a vertical expansion by 3 and a horizontal compression by a half? So we'll call this the left blank and we'll call this the right blank. So what should go in the left blank? Yeah, a 3 because it's been a vertical expansion by 3. Okay, so that's what goes there. What goes in the right blank? Be careful, be careful. Be careful, what goes in the right blank? 2 goes in the right blank. Okay, so now I have where I've taken my English, I've turned it into math. Now to turn it into transformation notation, to help me with this equation, what do I have to do?
A barrel roll.
A barrel roll again, yeah. So the vertical to one side, horizontal to the other. So if I look at these pieces, this is my horizontal, it can stay where it is. This is a vertical piece, it needs to go to the other side. So I'm going to have 1/3 y equals f of 2x. And that means what used to be x has now become 2x. What used to be y is now 1/3 y. So I can take this equation and make those replacements. This y here is going to become 1/3 y. Each of these x's is going to become 2x. So that'll be 3, 2x cubed, 2 times 2x squared. Okay, so that's the hardest part of it, is to get to the point where you can make those replacements. And now what all that's left to do is try and simplify it a little bit, so maybe it looks a bit more like a regular equation. So for example, I can expand these pretty quickly. This here would be 8x cubed if I expanded it. This would be 4x squared. This would be 2x. So 1/3 y is 24x cubed plus 8x squared minus 12x plus 4. And the last thing I can do to make it look normal is multiply it by 3 so that this fraction disappears. So I get y equals 72x cubed plus 24x squared minus 36x plus 12. So it's not obvious that that's the transformation that's happened, but it is, you know, if you can master those couple steps, you can take any equation and transform it just like you would a graph. Okay? So remember, with this kind of stuff in transformation notations, you are responsible to know how to do it. Typically, the most you'd have to apply to it is 1 or 2 steps. So this would be an example of like 2 steps because there's a horizontal and there's a vertical compression. But typically on a provincial exam, if this was something you're faced with, at most, I've never seen them go over 2. So you don't really have to be a super expert at it, but you have to be able to do it, you know, for at least 1 or 2 steps. Okay? So we will come across questions like this when we start to review. You'll see where they've been used in the provincial exams before to give you an idea if it's something you're comfortable with or not. Okay, so for today's homework,